If you are looking to add electric power to your model aircraft, you've come to the right video. The number of factors involved with electric power can be overwhelming. So we're going to focus on 4 key elements. By understanding these 4 key elements, we can put electric power in our model aircraft that will make it fly the way we want. The first factor is power. We need enough power to fly. We'll calculate it by multiplying our voltage times our current, and the units are going to be volts times amps equaling watts. And how much power is enough? At this point, we're just selecting the motor capacity. We may not be able to get every last watt out of the motor that it can deliver. So these numbers are a little conservative, they're a little on the high side, but if we choose a motor based on these guidelines, we should have enough power to fly the aircraft the way we want to. So for the typical sport flyer that wants to be able to do some aerobatics, estimate the full up weight of the aircraft, and then choose a motor that can deliver at least 100 watts per pound. A little information about how a brushless motor works will be helpful here. As the load goes to 0, RPMs increase to their maximum. At the halfway point, where the motor is running at half of its maximum or no load speed, this is where it generates its maximum power. If we set our system up so that the airplane is operating at max power or a little faster, sitting on the bench during a static test, then as the plane takes off, its RPMs are going to increase. This will put the motor in the operating range for maximum efficiency. And for a brushless motor, this is about 75 or 80% of its maximum no-load speed. The other motor characteristic that affects our battery and prop choice is voltage. Voltage equals speed in an electric motor. The higher the voltage, the faster the motor will try to spin. But if the prop is too large, there's too much load, we can overload the motor. The motor rating that tells us how it's going to respond is called the kV. Max RPM equals kV times the voltage applied to the motor. But since we want to operate at max efficiency when we're flying through the air in forward flight, ideally, then we really want to operate around 80% of this maximum RPM, or 80% of kV times voltage. Now, let's use this information to specify our battery pack. To specify our pack, or our battery pack, there are 2 critical things we have to decide on. One is the pack voltage, and the other is the pack capacity. For LiPo battery, the number of cells in series determine the pack voltage. Voltage per cell, it varies from about 4.2 fully charged to 3.75 discharged. For our estimates that we're making here, let's just call it 4 volts per cell. So for example, 3S would be about 12 volts. Now capacity is the energy that's within that battery. It's critical to ensuring adequate flight time. For a given battery, amp hour defines the capacity. That's 1 amp delivered for 1 hour. Now most LiPos used in model aircraft are pretty small, and so it's milliamp hours that they're specified in. 1 amp is 1,000 milliamps. So 1 amp hour is 1,000 milliamp hours. To estimate the capacity needed for a given system, a rule of thumb to ensure a flight time of at least 4 to 6 minutes is to divide the maximum number of amps by 15. We then multiply by 1,000, and that gives us milliamp hours. Now that's a lot of numbers. So how about we do a couple of examples. For a typical park flyer, about 380 watts, that would be about 32 amps. And it turns out that a 3S 2100 battery works out pretty well with this system. This is a very common park flyer size battery, and building a fleet of aircraft around this battery pack will let you share batteries between many aircraft. Another very common pack is a 4S 3200, something in that range. When we crunch the numbers, what we find is this pack is good for a larger airplane, 4 to 5 pounds, and a 6 to 700 watt motor. Pitch speed is how fast a prop would try to fly if drag from the plane wasn't holding it back. Many models fly happily with a pitch speed of around 60 miles an hour. There's some World War II warbirds that are happier with pitch speeds over 75 miles an hour, and there are trainers that fly with pitch speeds as low as 40 miles an hour. If we know what prop is recommended for a glow engine on a particular model, we can use this to tell us what pitch speed the model is happy with. We do that by applying a rule of thumb. At 10,500 RPM, the pitch speed in miles an hour is equal to the pitch times 10, if the pitch is specified in inches. Since 10,500 RPM is basically the RPM of a typical 4-stroke glow engine when it's in flight. Note, this is not the RPM on the test stand when you're tuning the engine. This is the RPM when it's flying. So this works out pretty well for us to quickly estimate the pitch speed for a given model. It's pitch times 10 if it's a glow engine attached to it. If our kV times volts, 80% of that turns out to be about 10,500 RPM, then we can apply the rule of thumb, and in fact the model will use a propeller with a similar pitch to the glow engine. Now if the RPM is lower or higher, then we have to adjust for the ratio, and this equation would allow us to calculate what pitch exactly we need to get the pitch speed. Now that we've chosen our pitch, the remaining parameter is our prop diameter. If it will fit, usually we use the largest prop that we can without overloading the motor. Now to figure this out, we can use manufacturer's recommendations. Sometimes they'll provide the data. We can use an online calculator, or we can make our best estimate and then verify this with a power meter on our setup on a stand, measuring the current draw used by the propeller on our system. No matter how we choose our propeller, it's always a good choice to at least verify the current draw with a power meter to make sure we don't overload our system. Now that we're done and we understand the propeller that's recommended by all the other things that we've done, we can look at the diameter to pitch ratio and see if the aircraft will fly in the way that we want it to. If the diameter to pitch ratio is about 1:1, like a 6x6 or an 8x8, this will not have a lot of thrust, relatively speaking, at takeoff. In fact, the propeller may be stalled at takeoff and really won't become effective until the plane starts moving forward. Common propellers for sport flying are around 1.5:1. At 2:1, we have propellers that we begin to use for 3D flying. And what's special about propellers in the 2:1 or higher range is that they have the highest thrust at takeoff. Not necessarily the faster propeller while we're flying around, especially out of a dive. In fact, they will tend to act like an air brake. But the ground handling capabilities of propellers with a diameter to pitch ratio of greater than 1.5:1 can make taking off and that aspect of the flight experience much more enjoyable. If we don't think the diameter to pitch ratio is ideal for the kind of airplane that we have, we can now go back, select another motor, and go back through the system to try and optimize it for the kind of flying that we want to do. Generally, KVs that are higher will result in smaller diameter propellers. KVs that are lower will generally result in larger diameter propellers if the motor has pretty much the same power. So if we're doing a World War I airplane, we might want to choose a relatively lower KV, or we may want to lower the voltage in our battery pack so that we swing a very large propeller because we want it to look scale. Certainly if we're doing a pusher jet where we want a small propeller that's going to go very, very fast, that's when we're going to look at higher KV motors. Now there are several other factors involved with speccing out a power system, such as the capacity of the speed controller. This is where your local hobby shop can be a great asset. If you understand the 4 P's, power, pack, pitch speed, and prop diameter, then you can visit your local hobby shop and they can help you with the rest to make sure that you spec out a power system for your aircraft that flies it the way that you want.